So combining functions algebraically. Instead of looking at the graph and going, that one's a y and that one's a b, and doing it just by looking at the table of values, now they want you to muck around with the formulas. So what we're going to do is start at the construct understanding on page 272 of your book, and I've just done a rough sketch with 1 point of the 3 graphs that they've used, but we're just going to go through the steps and you can look at the detailed graphs in your book. Now, to get started, what they want us to do is to determine how we combine these 2 graphs to get that graph. So the best way to go forward from that, we're going to do it 2 different ways. The first way is going to be the way that we've been doing it, which means we're going to do a table of values. So for this graph, I picked my x values to correspond with what they showed me on the grid, which was -2 to +2 on all of them. So I've got -2 to +2 written in here for my x values. Now I've gone and looked at the graph and read off my y values for each of those x values. For example, this graph had -2 here, and it hit the crosshairs of the graph at 4 on the vertical axis. So I wrote -2 and 4 as my pair. On this graph, the same point, -2, is down at -1, and on the final graph at -2, it's actually up at 5. So those 3 points are connected in some way. We just have to figure out mathematically how they're connected. So I wrote 4 and -1 and 5. And then I continued to do the same thing for each of the lines on the x-axis, so -1, 0, 1, 2. Figured out what points coordinated with them for each of the 3 graphs and listed them. Now what we want to do is look at that list and find a pattern. So how do 4 and -1 get me 5? Well, I could go 4 minus 1, that would get me 5. Would 1 minus 1 get me 0? Yes. Would 0 minus 3 get me -3? Would 1 minus 5 get me -4? And so on. So what we see happening here is that the pattern reveals that it's actually f of x minus g of x that gets us h of x. So we're just going to write that down. F of x minus g of x gets us h of x. So that was a little bit of work, going through the table and looking at the values and stuff. What we want to confirm with that, and this is kind of where we're headed after this, is can I do this algebraically? So if I were to take this and subtract that, would I end up with a formula that looked like that? So let's try it. Let's write in f of x is x squared, and I'm just going to subtract 2x plus 3 in brackets. And then I'm going to see if it equals. We're just going to put a little question mark over the equal sign there and write in the x squared minus 2x minus 3. So I'm going to give myself a little room here because I don't want to run out of space. I'm going to erase this. And I want to kind of look at this a little more carefully. So x squared minus 2x would be minus 2x, just like that. But minus a +3 would make that a -3. So I'm going to have x squared minus 2x minus 3 as my full function once I multiply that negative through the brackets. Does this match this? Why, yes. Yes, it does. So you can see how we algebraically subtracted this from this and ended up with this guy. We're going to move on to doing that kind of thing so that you can do this stuff in your calculators by fixing the formula first, then putting that in your calculator, instead of having to go through the tedium of looking at the individual graphs, writing out the tables, and so on. So the point of this exercise was just to see that you can get the same answer if you simply combine the formulas in the first place, and then you just get your final graph.